Something is wrong with reality. Not in a poetic sense, not in a life feels weird kind of way. In a cold, mathematical, peer reviewed, published in the most respected physics journals on the planet kind of way. Because what Google's quantum computer just found, what it actually detected, buried inside the mathematics of reality itself, has left some of the smartest people who have ever lived sitting in silence, staring at data they cannot explain. And once you understand what they found, you will never look at the world around you the same way again. Stay with me, because this one goes deep. Let's start with something you've probably never thought about. Right now, as you're watching this, every single object around you, your phone, the wall, the air itself, is made of atoms. And those atoms are made of smaller particles. And those particles, when you zoom all the way in, when you get to the absolute basement of physical reality, they stop behaving like things. They start behaving like possibilities. This isn't philosophy. This is quantum mechanics. And it is the most precisely tested, most experimentally verified theory in the history of human science. It is more accurate than any other framework we have ever built. And what it tells us about reality is so strange that Richard Feynman, one of the greatest physicists who ever lived, once said that if you think you understand quantum mechanics, you don't understand quantum mechanics. So what does quantum mechanics actually say? It says that before you observe a particle, before you look at it, measure it, interact with it in any way, it doesn't have a definite position. It doesn't have a definite speed. It exists in what physicists call a superposition, a combination of every possible state it could be in, all at once. The moment you observe it, the moment any kind of measurement happens, it snaps into one definite reality. But here's the question that has haunted physics for over 100 years. What is causing that snap? What is the mechanism? What decides which version of reality becomes real? And does the act of observation, of conscious awareness, actually play a role in determining what physical reality looks like? These are not small questions. These are the deepest questions physics has ever asked. And for most of the last century, most scientists agreed to look away from them, to just use the math, get the right answers, build the technology, and not ask what it means. But a few months ago, Google built something that forced everyone to look again. The device is called Willow. It is Google's most advanced quantum processor. And what makes it different from every computer that came before it, including every quantum computer that came before it, is not just its speed. It's what it found when they let it run. To understand why this matters, you need to understand what a quantum computer actually is. A regular computer, the one in your phone, the one in every server running the internet, processes information using bits, zeros and ones, off or on. Every calculation is a sequence of those binary choices, billions of times per second. A quantum computer uses qubits, quantum bits, and a qubit doesn't have to be a 0 or a 1. It can be both at the same time, in superposition, which means a quantum computer doesn't just try one path through a problem, it explores every possible path simultaneously. The implications of that are almost impossible to overstate. A problem that would take a classical computer millions of years to solve, a sufficiently advanced quantum computer can solve in minutes. Not because it's faster in the conventional sense, but because it's exploring the solution space in a fundamentally different way. A way that mirrors how reality itself seems to work at the quantum level. And when Google's Willow processor was tested, it solved a benchmark problem in under 5 minutes. A problem that would take the most powerful classical supercomputer we have built, a machine called Frontier, 10 septillion years to solve. 10 septillion. That is a 10 followed by 24 zeros. That is not just longer than the age of the universe. That is longer than the age of the universe multiplied by itself many times over. So, the machine works spectacularly. But the question that kept coming up in the physics community afterward wasn't just how fast it was. It was, where is the computation happening? This is where things get deeply strange. When a quantum computer solves a problem, it explores all possible solutions at once. It runs through every branch of the calculation simultaneously. And it does this so efficiently, so completely, that some physicists have been forced to ask a question that sounds like science fiction, but is, in fact, serious academic physics. Is the quantum computer doing part of its work in other versions of reality? This idea has a name. It's called the many worlds interpretation of quantum mechanics, and it was proposed in 1957 by a physicist named Hugh Everett III. Everett's idea was radical. He said that the wave function, that mathematical object that describes all the possible states a particle can be in, never actually collapses. When you observe a particle, when a measurement happens, reality doesn't snap into one version. Instead, reality branches. Every possible outcome happens, but each outcome happens in a separate branch of the universe, a separate world. And those worlds don't interact with each other. They can't see each other. They don't know about each other, including us. We only ever experience one branch, but all the others exist now. If this sounds like a convenient idea that can never be tested, that's what most physicists thought for decades. But a quantum computer, according to some of the most serious thinkers in the field, might be the first technology that only works if the many worlds interpretation is correct. Because if a quantum computer is genuinely exploring all possible solutions simultaneously, and it clearly is, the results prove it, then where exactly are all those parallel calculations happening? The classical answer is interference. Quantum states interfere with each other inside the machine, like waves on water, and the right answer emerges from the pattern. That's the standard explanation. But Oxford physicist David Deutsch, one of the founders of quantum computing theory, has argued for decades that this explanation doesn't fully hold, that the computational power of quantum computers is evidence, real, physical evidence, that those parallel calculations are happening in parallel branches of reality, not metaphorically, literally. And if he's right, then every time Google's Willow processor runs, it is reaching into other versions of the universe to borrow their computational power. Sit with that for a moment. But let's go deeper, because the many worlds question is just the beginning of what quantum mechanics is forcing us to confront. There is another problem, a darker one, and it goes by a name that is almost too simple for how disturbing it is, the measurement problem. Here is the core of it. In quantum mechanics, particles exist in superposition, in all possible states, until they are measured. The measurement causes the wave function to collapse into one definite outcome. That much everyone agrees on. What no one agrees on is what counts as a measurement. Does it have to be a conscious observer? Does a camera count? Does a rock count? If a particle interacts with another particle and no conscious being is watching, does the wave function collapse? This question has never been answered. Not in over 100 years of trying. And the fact that it hasn't been answered means that the most fundamental theory in all of physics, the theory that underlies all of chemistry, all of biology, all of material science, everything your phone is built on, contains at its very heart a concept that no one can define. What is an observation? Some physicists have taken this seriously enough to propose that consciousness itself is not a byproduct of physical reality, not something that emerges from neurons firing, but is instead a fundamental feature of the universe. That mind is not produced by matter. That matter is somehow produced by, or dependent on, mind. This is not mysticism. This is published, peer-reviewed, serious physics. The physicist Roger Penrose, who won the Nobel Prize for his work on black holes, has spent decades arguing that consciousness cannot be explained by classical computation and may be connected to quantum processes at the microtubule level of neurons. His collaborator Stuart Hameroff has extended this into a framework called orchestrated objective reduction. The idea that conscious experience is literally a quantum event happening inside your brain billions of times per second. If they are right, and they may not be, this is contested, then you are not a passive observer of a universe that exists independently of you. You are a participant. Your observation, your awareness, is part of the mechanism by which reality becomes real. And now, Google has built a machine that makes this question impossible to ignore. Because here is the detail that nobody is talking about enough. When Google's team analyzed the errors in Willow's computations, the noise, the decoherence, the places where the quantum states broke down, they found something they did not expect. The errors were not random. They had structure, pattern, and that pattern followed what physicists call a threshold behavior, a sudden, sharp transition, like water turning to ice. Below a certain threshold of error correction, the system behaved one way. Above that threshold, it behaved in a completely different way. A way that shouldn't be possible under classical physics. A way that only makes sense if you assume the quantum states are being stabilized by something. Something outside the system itself. Now, the official interpretation from Google's team is that this is evidence their error correction is working. That the quantum system is self-correcting in a way their models predicted. But several independent physicists looking at the same data have asked a harder question. If the error pattern has structure, if it follows a predictable threshold, then what is imposing that structure? What is the source of the pattern? And some of them have arrived at an answer that sounds almost spiritual, but is grounded in mathematics. The pattern might be evidence of constraints, fundamental constraints built into the fabric of reality itself. Mathematical rules that reality is required to obey. Not rules that emerge from physical processes. Rules that were there first, before the physical processes shaping what is even allowed to exist. In other words, reality might not be a physical thing that happens to obey mathematics. Reality might be mathematics, and the physical universe might be what mathematics looks like from the inside. This idea has a name. Max Tegmark, a physicist at MIT, calls it the mathematical universe hypothesis. And the argument goes like this. Every physical structure we have ever found, every particle, every force, every law of nature, can be described with perfect accuracy using mathematics. Not approximately, perfectly. The equations don't just model reality, they match it, at every scale, with infinite precision. And Tegmark asks, why? Why is physical reality so perfectly mathematical? The standard answer is that mathematics is just a language we invented to describe reality. A very good language, but just a description. But Tegmark says this is backwards. Because if mathematics is just a description, then there should be some physical things that mathematics can't quite capture. Some irreducible messiness that the equations can only approximate. Some leftover reality that isn't mathematical. But there isn't. Every time we look deeper, every time we zoom into a smaller scale, or look at a larger structure, the mathematics gets more precise, not less. The equations don't break down, they get more elegant. Which means either we are unbelievably, cosmically lucky that reality happens to be perfectly mathematical, or mathematics is not describing reality from the outside. Mathematics is what reality is made of. And if that's true, then what you are, sitting here, watching this, thinking about it, is a mathematical structure that has become complex enough to contemplate itself. Your consciousness, your sense of being here, your experience of time passing and thoughts forming. All of it is a pattern in mathematics. An equation that became aware. Is that unsettling? Or is it the most profound thing you've ever heard? Now let's talk about what happens when you combine all of this with what Google's machine just proved. We have a quantum computer that only makes sense if parallel realities exist. We have a measurement problem that has never been solved, that forces us to ask what the role of consciousness is in creating physical reality. We have error patterns in quantum systems that suggest reality is constrained by mathematical rules that were there before the physics. And we have a serious scientific framework, the mathematical universe hypothesis, that says reality isn't physical at all. It's mathematical, and the physical universe is just one particular mathematical structure among an infinite number of others. Put all of this together, and you get something that might be the most important idea physics has produced in a century. We are not living in a physical universe. We are living in an information structure, a mathematical object, something that processes itself, something that at its deepest level is not made of stuff. It's made of relationships, of rules, of patterns that reference each other in a vast, self-consistent, self-organizing web. And the quantum computer is the first tool we have ever built that reaches down into that web and pulls on the threads. So now I want to ask you something, and I want you to really think about this before you answer. If reality is fundamentally mathematical, if the laws of physics are not rules imposed on reality from outside, but are the actual structure of reality itself, then what does that mean for the question of why there is something rather than nothing? The traditional answer to that question has always been, we don't know. Physics can't answer it. Science can't answer it. It's either a philosophical question or a theological one. But if reality is mathematics, then the answer might be different. Mathematical truths don't need a reason to exist. 2 plus 2 equals 4, not because something made it true. It is simply true. Necessarily, inevitably, eternally true. No cause required. No creator of the rule needed. If the universe is a mathematical structure, then its existence might be the same kind of thing. Not something that was caused, not something that required a beginning, but something that simply is. Necessarily, inevitably, the way 2 plus 2 is necessarily 4. And here's where I want to stop and be honest with you. This is where physics reaches its limit. This is where the equations end and the questions begin. Because even if the mathematical universe hypothesis is correct, it doesn't answer everything. It just pushes the deepest questions further back. Why does mathematical existence feel like something? Why does this particular structure have experience? Why is there a you sitting here having this thought? Those questions remain, and they may always remain, not because we aren't smart enough to answer them, but because they may be questions that exist outside the system that is asking them. The universe, trying to understand itself, using itself as the only tool it has. Think about what has happened in your lifetime. And I don't mean years, I mean the last few months. We have built a machine that solves in 5 minutes what would take the age of the universe to compute classically. We have found error patterns in quantum systems that physicists are calling a threshold, a signature that reality is constrained by something deeper than physics. We have Nobel laureates publishing papers that cannot rule out the possibility that consciousness plays a role in collapsing physical reality into existence. We have serious academic frameworks proposing that the universe is not a collection of particles and fields, but an infinite mathematical object experiencing itself. This is not the fringe. This is not speculation dressed up as science. This is where the cutting edge of human knowledge has arrived. And the honest answer, the answer that the bravest physicists are willing to give on the record, is that we don't know what it means yet. But we know something enormous is happening. The picture of reality that most of us grew up with, solid, physical, mechanical, independent of the observer, is being dismantled. Not by philosophers, by the mathematics itself. And what is being built in its place is something stranger, something more intricate, something that puts the question of consciousness right back at the center of physics, right where some of the founders of quantum mechanics always believed it belonged. Now, before I ask you the question I really want you to think about, the one I want you to leave in the comments, because I genuinely want to know what you think, I want to say something about this channel. Everything we do here takes serious time. The research alone for a video like this takes days. Cross-referencing papers, checking sources, making sure nothing is overstated, finding the actual data behind the headlines. We never want to mislead you. We want to earn your trust with every video. If this kind of content means something to you, if you want us to keep going deeper, keep making these long, careful, cinematic explorations of the biggest questions in science, the most meaningful thing you can do is hit the like button right now. It costs you nothing, and it tells the algorithm that this kind of serious, thoughtful content deserves to reach more people. And if you want to go further, if you want to be part of what we're building here, we have a Patreon. The link is in the description. Every single contribution, no matter how small, directly funds the research time that makes videos like this possible. We're not a massive channel. We're a small team that cares deeply about getting this right. And your support is the only reason we can keep doing it. Subscribe if you haven't. And turn on notifications, because what we have coming next is going to go even deeper than this. Now, the question, and I want you to take a moment before you answer. Actually think about it. If reality is mathematical at its core, if the physical universe is not the foundation of existence, but is itself a structure inside something deeper, then what does that say about consciousness? Is your awareness just a pattern? A self-referencing loop in a vast equation? Or is consciousness the thing that the equation is for? The reason the mathematics becomes real instead of just abstract. And here's the version of that question that I can't get out of my head. If observation collapses quantum possibilities into physical reality, if the act of awareness is somehow part of the mechanism by which existence becomes definite, then what was collapsing reality before conscious beings evolved? Was anything real before anyone was here to observe it? Leave your answer below. Genuinely. I read every comment on this channel, and I want to know where you land on this. Not just mind blown, but your actual thinking, your actual intuition. Because some of the most interesting ideas I've encountered have come from people in this comment section. People who think carefully about these things and aren't afraid to say something real. What do you think reality actually is? And if this video reached you, if something here landed, share it with one person, just one. Someone you think would want to sit with these questions. Someone who doesn't just want easy answers. Someone who can handle the idea that the universe might be stranger, deeper, and more connected to their own existence than anyone told them. Because that's who this channel is for. And that's why we're still here making these videos. We'll see you in the next one.